Hello, a good evening, Programmer's Life. Back from where we ended the previous time. Now we ended when we had combined two concepts, that is, using arrays and functions. So for this session, I want us to look at something that is even more interesting than what we have looked at earlier. So for that case, we shall have a new file. So today, this session, I want us to look at pointers and references. Okay, I remember within our previous episodes, just to check through, we had given a starting point that we are to follow. We are to talk about arrays, then pointers, then references. So we managed to talk about arrays and we saw the details within. Then for today's session or episode, we are going to look at pointers and references. Now, something is really important. Each time you create a variable, okay, each time you create a variable, at every variable declaration, okay, memory is reserved. I think each one of us knows this by now. At every variable declaration, memory is reserved. Now this memory has what we call a reference. For starters, I'll put it here. This memory has what we call a reference, or we call it an address. Okay, so it means that for us to know where that memory location is, then we point to that memory location through its address. Now these addresses are assigned by the compiler at the time when we are really working with this program. So that is basically about a variable. Now when it comes to a pointer is a variable too. A pointer is a special variable that holds an address of another variable. Okay, the variables that we know have been holding values. Okay, now here we are looking at a variable that is holding an address of another variable. Okay, so this pointer variable is defined to, we can say, point to data of a specific type. Okay, data of a specific type. That is what we call a pointer. So we are going to talk about pointers in details along the way, but there is something that is also so important that we need to work hand in hand with. Then we have what we call a reference. or we have what we call references. Now, a reference is an alias. A reference is an alias. Sorry about that. A reference is an alias for an already existing variable. Okay, we have a variable, so we are saying is an alias for an already existing variable, and I was saying that we have a variable in place already, then we have its representation. So what I can say is once a reference is initialized, I'm typing so that we can have the reference at a later stage. Once a reference is initialized to a variable, it can't be changed, so meaning it's fixed. Okay, it cannot be changed to refer to another variable. Okay, so what I mean in this case is that this can be considered as a constant pointer, something of that sort. I'm saying what we are looking at today or right now is pointers and references. Now I promised that along the way we are going to talk about pointers in details, and definitely we are going to talk about references in details. So what we are having right now is just an opening of the two. Let's try to have an idea about pointers, and let's try to have an idea about references. Now, someone might ask, within the explanation I've said it is kinda of a constant pointer, so where is the difference? Someone might ask, where is the difference between the two? So differences between the two, I'll begin with pointers to not. Okay, now a pointer can be initialized to any value anytime after it's declared. So I can say after declaration, pointer can be initialized to any value at any point in the program. That is something important that we need to note. Then we shall know what that means later. Of course, we need to connect up. Then a pointer needs to be dereferenced. Pointer needs to be dereferenced. We shall know what dereferencing means, but of course dereferencing is something like that. Okay, so pointers need to be dereferenced. We shall see what that means. Then another pointer can be assigned to point to a null. Guys, let's first mark them just the way they are, so later of course when you talk about the details, then more things will make quite some sense. So you can look for more details from that section, just in case if you're making research. Then let's talk about references. Now, a reference cannot be a null. A reference can't be a null. Okay, but a pointer, we've said, can be assigned to point to a null. Another, a reference must be initialized after declaration. So remember, we said this one is known as a constant pointer, so no more initializations after that initialization. That is why we said once a reference is initialized to a variable, it can't be changed to refer to another variable. So here we are saying that a reference must be initialized after declaration. Yet we said that when it comes to a pointer, it can always be assigned a value at any point within the program. Okay, so we need to jot that down too. So references can simply be used by their names. That is something that is also important. And lastly, once a reference is initialized, we talked about that already, but we need to say it again. Once a reference is initialized to a variable, we said it can't be changed to refer to another variable. Okay, it cannot be changed to refer to another variable. Now, those are some of the differences that we can clearly spot out when it comes to pointers and references. Now let's go back. Okay, let's go back. We said a pointer is a special variable that holds an address of another variable. So in the next bit, let's try to look at pointers in details. So syntax of a pointer. So it's gonna be data type, then a dereference operator, and an identifier. What have I done? I have declared a pointer altogether, guys. So I can say examples. As usual, view syntax is C++. Okay, I didn't want to change, but I have to. But maybe something is not okay here. Where did the problem come from? Problem came from there and here, because I want things to be clear. Okay, so I'll come back to this point. I can say int ptr. I can say char my char. I can say float ptr2. Okay, now this is an integer or integral pointer, this is a character pointer, and this is a floating pointer. So what am I doing? I'm declaring a pointer, and we've said the syntax is data type. okay, then a dereference operator, then an identifier. For this case, an identifier, it means the name we are giving our pointer. Okay, so the name that we are giving to the pointer follows the same rules of variable naming. So it means we are clear as of now. Now this symbol is called a dereference operator. Of course, in multiplication it is called a multiplication sign. Then when it comes to pointers, it means a dereference operator. I think we are moving. Okay, so by doing that, I have declared a pointer. Now if at all I come and say int, because someone might ask what's the difference between them. If I come and say int ptr without a dereference, this is a normal variable declaration. Okay, and this is pointer variable declaration. I think we are now picking the two. So a mere putting of this, it means you're declaring a pointer. Without it, it means you're declaring a normal variable. Now when pointers come into play, there is quite a lot that really happens in this case. Now if we are to use pointers, the first thing that someone needs to keep in mind is what rules do we follow. I told you programming is about grasping the rules and knowing when to apply what. So if we are to use pointers within our programs, these rules have to come to play, or these rules have to be at the fingertips of a programmer. Now one is a pointer should be of the same type with the variable that it expects. It expects to keep track of its address. I don't know if I'm making sense. Let's read through again. A pointer should be of the same type with the variable that it expects to keep track of its address. What do I mean? Okay, something to note. If the pointer is of an integer type, then the variable should also be integer. The variable should also be integer. This is what we mean. You can say int num, okay, and num is containing 90. Then I can say float x, and x is containing 8.9. Then I can say int pt, which is a pointer variable, okay, and I can still say float p, which is also a pointer variable. Okay, but they are saying if the pointer is of an integer type, then the variable should also be an integer altogether. So it means that we shall say this is for num. Okay, this is for x. I think it makes sense. So that is should say rule number 1. Don't mind about the order, but mind about grasping or understanding the rules. Now rule number 2. Rule number 2: if a pointer is non-dereferenced, then it expects an address of a variable not a value. Saying that if a pointer is non-dereferenced, then it expects an address of a value, not an address of a variable, not a value. So what do we mean by this? Example. I'm going to use the example from above, from here. So we are saying if it's non-dereferenced. So non-dereferenced means that if I say pt, then it is expecting an address of num. Okay, this is correct. But if I say pt is having 80, okay, then this is wrong. Hope we are moving. The rule says if it is non-dereferenced, then we can say a dereferenced pointer expects a value of the variable to which it tracks the address, but not an address of that variable. I don't know if it is making quite some sense. A dereferenced pointer expects a value. So it means that if I say a dereferenced p, then I say it's containing an address of x, then this is wrong. Okay, but if I say a dereferenced p is containing 4.5, then this is okay. Okay, and that is okay. Hope we are picking. Of course we are going to do some examples practically, and that will make sense. Okay, then a pointer that points to a null is known as a null pointer. Pointer that points to a null is known as a null pointer. Okay, guys, we are moving. Are we moving? Okay, now for us to understand this maybe a little bit well, let's have a new let's have a new program. This is among the programs that we had in the previous episode, so we don't need anything here. Okay, we don't need anything there. Just want a fresh program. So here I'll say using pointers. It's a basic program. So here I'll come and say main. Okay, now we are going to have a pointer declaration here. At this point I can say int p, then I can have a normal variable, my var, which is assigned that. Then I can have float xyz, which is a normal variable. Then I can have ptr, which is a pointer variable. So pointer declaration, so it's pointer and normal variable declaration. Then later I'm having p is containing the address of my var. Okay, this symbol, this ampersand, is known as address of. So this is perfect because we said a non-dereferenced pointer is not expecting a value, but it is expecting an address of a variable. So pointer points to the address of my what? My var. Together. So what is going to happen? So I can say cout. Let's begin. I can say address of my var, address of my var. You can read it from here. Address my var. So if I want to know the address of my var, I can just reference in that way. Okay, and still say out address of my var, address of my var. Remember line 10, a non-dereferenced pointer p is containing the address of my var. So if I want to know the address of my var, I can just print p. It definitely makes a lot of sense. Then I can also track the address of the pointer, address of the integer pointer. Okay, here I can even make it more understandable. Address of xyz, address of xyz, it means address of xyz. I have a variable called xyz. So once again, at this level I can say ptr is assigned the address of xyz. does it mean? I can say the address of XYZ is PTR. I think it makes some sense. So here I can do the same. The address of P. Okay, the address of P, I can read it from here. Okay, the same thing applies. I can read the address of the float pointer. So that is the address of PTR. It can be the address of PTR. I think we are together. Okay, then I can say I need to copy, but let me just type. And I can say the value of my var, is a dereferenced PT. Does it make sense? That's it. I think we are moving. Okay, so you remember we said a dereferenced PT, the dereferenced pointer is containing a value but not an address. So what do I mean? I mean I can say a dereferenced PTR is assigned a dereferenced P. So what have I done? I have assigned the value of my var, that is indirectly, to XYZ. Does it make sense? So if you want to prove, I can say out the value of XYZ is we can use XYZ. Reason being, if you try to notice at the declaration here, we never assigned XYZ a value, but we are dropping it inside here. So the same statement can be modified a bit. The value of XYZ is the referenced PT R. So ladies and gentlemen, we are trying to understand the basic concepts of using pointers. I don't know if we are together. Are we together? Are we moving? So I know if you have any questions within this section, please just subscribe to my YouTube channel if you haven't. Then reach me out on +256 751 824973 or on my email programmerslife@gmail.com. Definitely I'll be able to answer your questions as you wish. So from here, automatically our next bit is to go to the kitchen and do some cooking. Okay, we are in the kitchen now. We are trying to see how it connects. Okay, but we have an error on line 20. Error PT was not declared, line 20. So yeah, this is PTR. So we run again. Now if you try to notice, There you go. Now these values are dependent on the values are dependent on your machine architecture. Okay, so the nature of your machine, the nature of your memory addressing will determine some of these values, more so with the addresses, but I think you can see how this can really work. Okay, so the value of my var is the reference to PTR. The reference to PTR, yeah, we don't have a value, so that is okay. So the value of XYZ, we used the actual variable, and we even used the pointer, and that is really clear in that case. So you see, this is how addresses are in hexadecimal format. So if you want to know where this is stored, definitely that is the address. So that is how addresses are given within the machine. But what was important here for starters was how do we use arrays and what rules do we follow when we are to implement, they are pointers, not arrays. So I think that is clear as of now. Okay, so still under pointers, let's try to look at more. And I love it when we dig deep so that we really understand. Now in C++, you can always have another concept which is called pointer arithmetics. We can do some bit of arithmetics when we are handling pointers. Now someone is saying, hey, you mean we can do some bits of computations when it comes to addresses? We can see that, but generally what I want to say is pointers can allow what we call arithmetics. Now in C++, someone can do the following. Someone can add in C++, someone can add an integer in C++, someone can add an integer quantity. I think this has always been happening, or subtract an int quantity. I think that is known. Okay, but this time around from a pointer. So that is something that I want you to know, that in C++ someone can add an integer quantity or can subtract an int quantity from a pointer's view. Okay, and this is, by the way, used by programmers. This is used by programmers, and it's what we know as pointer arithmetic. So right now, allow me be the chairman of programmers, and I'm using it and I'm talking about it right now, and we are going to get more details about it. So you can do the addition, you can do the subtraction, and this is what we call pointer arithmetics. Okay, now one thing that you need to note when it comes to pointer arithmetics, it's not the same as when it comes to pointer arithmetics, it's not the same as integer arithmetics. It's not the same as integer arithmetics. Are we clear? I'm moving a little bit slowly. Purpose is to understand. Someone might ask why. Okay, someone might ask why. Okay, let me jot it here. because the outcome depends on the size of the object that is being pointed to, because the outcome, okay, the outcome is dependent on the object that is being pointed to. I know some of these things, those guys who have been making research and know something about the language have not yet experienced, but we are here to talk about them. Okay, now what do we mean by this? As usual, I love life of examples. Okay, now here I need total attention for us to pick what I'm saying. Now for example, suppose we had an int. Okay, suppose we had an int which is in representation, it has 4 bytes. I think everyone knows this by now. I'm saying suppose we had an int in which by representation it has 4 bytes. Basing given char as an array string, as a string pointer, and it's containing a value hello, assume. Then we have an array still of nums, to which we might not identify the size as of now, but we shall depend on the number of items that we have inside. Okay, and then later we are saying int ptr, and ptr is containing the address of nums. Now something that we need to jot out here, I'm saying where did we begin from? I said pointer arithmetics is not the same as integer arithmetics. Then I said reason, because the outcome is dependent on the object that is being pointed to. Then I said assume we had an int, which of course we know is 4 bytes in representation. Then we have an array of characters down here on line 69, which is saying hello. Okay, then we are having on line 70 we have an array of integers and it's containing those values. Then on line 72 we are declaring an array we are declaring a pointer which is called ptr, and it is being assigned the array that is declared on line 70. Now line 72, in the policy of handling pointers and arrays, okay, in the policy of handling pointers and arrays, the idea is if you assign an array to a pointer, it means that the pointer picks the very first address, or it picks the address of the very first element in the array. Of course we shall come back to that, but our idea right now is we are talking about pointer arithmetics. So this one points to the first value of the array, so it means that if you check inside here, then definitely we shall be picking the address of 10. Okay, so it means that will be 10, that value, if you try to read at that point. So what does it mean? Okay, what does it mean? It means that if if I had a scenario, okay, if I had a scenario, assume that str is incremented, okay, so it will advance str by one character, okay, which means that is one byte altogether. So that it points to the second character of hello, so it will point to the second character of hello. So automatically it means that each time we make an increment, it means that str moves by a single character, which is that is 1 byte. So it will move to the next character of hello, okay, so it means it will move to E. Whereas if I move ptr in an incremental form, okay, what do you think is going to happen? It advances, or it moves ptr by 1 int, okay. Definitely those are how many bytes? Those are 4 bytes that moving, because here if my initial assignment is 0, then definitely that will be 10. So an advancement of ptr by 1, it means I'm moving to the second number within the array. I don't know if that is really clear. So it advances ptr by one value in the array, or by 1 int. Definitely those are 4 bytes, okay. Why? So that it points to the second the second num in the array. I think that is obvious. I wish I had a way to illustrate, okay, but I'll do it next time, no worry, when I have the possibility to. So it means that an increment of ptr, I'll be advancing, so it will be moving away from 0 to 1 to character 20, I mean to num 20, or to number 20 as an element. If it comes to this string, it means that if I increment this, I'll be moving away from the current character to the next character within the string. So it is a shift of 1 byte, and here it is a shift of 4 bytes, okay. So what does it mean? What does it mean in this case? What does it implies in this case? So when I'm talking about hello, what is gonna happen? So it can be referenced as what? It can be referenced as str, which is string, okay, or we can have pointer to str plus 1. Now pointer to str plus 1, it means that I'm shifting the current address, okay, I'm shifting the current address of that array of characters by 1, so it means I'll be in the next address. So earlier on, if I was on 0, then I'll be shifting to 1. So if 0 was h, then if I shift to 1, then it's gonna be E, a continuous movement. Okay, so if I continue, so it means this one is going to be 0 for understanding, then this one is going to be 1. So let me comment down and up, but before that let's first finish this. So it means that I'll have another one here, it will be str plus 2, so a continuous movement, and this will be this will be etc, so it will be a continuous movement. So up I'm commenting, this is in terms of addresses. This is in terms of addresses. So if I say str, that is the very first element within the array, so it will be 0. Okay, it will be 0, then this one will be 1, and this one will be 2. So in actual movement of values, so at 0, that is where we are having H. Okay, at 1, that is where we are having E, then at 2, that is where we are having the first L. I think, guys, we are moving now. Similarly, okay, guys, that is what we call programming, and we are looking at C++. If I am able to have all these things in my head, then definitely you can also do the same. So I'm helping you understand. So this is the reference to the string array, or the array of characters that we have up there. But don't forget, we have two arrays. We have one for nums and we have one for the characters. So similarly, when it comes to the numbers, or the nums array, okay, so let me come here and let me do this, because that will be the easiest way of understanding based on the previous explanation. So by this, it can be referenced as, so definitely we are going to have ptr. I told you that picks the very first address of the array, so it will take the very first number, which was 10. So again, we shall have this. By the way, we are going to have something similar to this in the next bit. So this one will be incremented by 1. This one will be ptr plus 2. Okay, and let's finish it. It will be ptr plus 3. Okay, so in addressing, this is 0, 1, 2, 3. In values, this is 10, 20, 30, 40. I think we are together. So that was basically increment, or moving through the addressing. Okay, now I know someone is confused, but let me cut the confusion. Now the confusion here would be, let me use nums. So in referencing, if it was actual referencing without using pointers, this would have been nums into 0. Okay, this one would have been nums into 0, then this one would have been nums into 1, then this one would have been nums into 2. Okay, then the last one would have been nums into 3. Ladies and gentlemen, this is exactly the same as that. Okay, the only difference here is I'm showing you one some form of arithmetics when it comes to pointers that I can increment from one address to another to access the values. Then 2, I'm following the policy that if I'm using pointers with arrays, that is how I do the referencing altogether. So that was addition basically. Another bit or another form involves subtracting. Okay, subtracting 2 pointers of the same type. Okay, how can we do that? So assume we still have int ptr1, and it is containing the address of nums into 1. Definitely, I think you know the value at that level. This value is what? Is 20. I'm basing on this. So again, I have int let's say ptr2, and this is containing the address of nums into 3. So nums into 3, definitely I think that is 40. Just helping you to understand. So if I have int result is ptr2, okay, minus ptr1. So what are you going to get? What are you going to get? Okay, so n is going to be containing what? N is going to be containing 2 in terms of addressing. So it's going to be containing 2, but if it is containing 2, then of course indirectly it will be containing 20, because it was 3 minus 1, that is 2. So if it is 2, what is in address 2? 0, 1, 2. What are we going to have? 0, 1, 2, that is 30. Okay, I hope you have discovered something out of that, but that is something that we call array arithmetics. Now in the next bit, I would want us to look at pointers, then arrays, then functions, but for now allow me to sign out. Don't forget to subscribe to my YouTube channel, Programmers Life.